Hi, my Math 130s. Today we are going to be going over Chapter 7, Homework Alternate Assignment. So yesterday with the LAC 130 group, we got through numbers 1 through 4. Today I'm going to continue. I'm hoping to get through at least number 9, but possibly number 10. And then the rest of the week I'll continue with this. And let me go ahead and put a date on here too. That's the 12th. All right, let me clear this out. So I'll post the other video, the one that I have from yesterday, later today. First thing I'm going to get into is number 5 here. Compute the value of the discriminant and give the number of real solutions of the quadratic equation. So we're actually going to pull off into a whiteboard for a minute. So I can go further into the concept of the discriminant. Okay, that's not working. Second day technical difficulties. I mean, I guess this is pretty much everyday technical difficulties, but okay. So for chapter 7, the discriminant of a quadratic expression or equation. So suppose you have this quadratic expression here. Ax squared plus bx plus c equals expression. Remember, to make it into an equation, you have the equal 0 aspect. And we talked about this yesterday. The quadratic formula gives the solutions to this particular quadratic equation here, okay? And the solutions x are given by negative b plus minus square root b squared minus 4ac, all divided by 2a, okay? Now, where does the discriminant come in? The discriminant is the part in the quadratic formula underneath the radical sign, okay? So in general, you could still have a discriminant from just the expression because you only need a, b, and c for it. So b squared minus 4ac. Now, there are 3 cases for the discriminant. And it basically, these cases tell us how many real or complex solutions we have for our quadratic. So suppose you have b squared minus 4ac. Actually, let's just draw it in 3 times so we don't have to worry about this later. Okay, so suppose for case 1, your discriminant is greater than 0. Okay, what that tells you is you're going to get a positive number underneath your radical sign if you use quadratic formula. And if you have a positive real number, say b squared minus 4ac comes out to whatever, 16. Okay, then when you take the square root of 16 with the plus minus in front here, you're either going to get a positive 4 or a negative 4 from your result. Both of these are real numbers. Okay. So if your discriminant is positive, you get two real solutions. Okay, so that's your first case. Your second case, suppose your discriminant is equal to 0. Well, that means that b squared minus 4ac would be 0. When you plug it into quadratic formula, you're taking the square root of 0 with a plus minus in front. But remember, the square root of 0 is only 0, right? So you'll get 0 for both cases. That means you only have one real solution, one real distinct solution. So if your discriminant is equal to 0, you have one real solution. You can probably guess what the last case is going to be in terms of the relationship to the discriminant in 0. When the discriminant is less than 0, then you'll get a negative number inside the radical. So suppose you have a negative 16, and then you're taking that square root with a plus minus in front from the quadratic formula. Well, remember we talked about I at this point. So you have a plus minus. This part is going to become square root negative 1 times 16, which is square root negative 1 times square root 16. Let me move this up a little bit. I'll spare that one. Okay, so then we have plus minus still. The definition of the square root of negative 1 is I, and the square root of 16 is 4. Okay, so essentially what we're getting here we have two solutions that come out. One is positive 4i, one is negative 4i. So you have two solutions, but because there's an I in them, they're complex. Okay. So now what that means is you have two complex solutions. Another name you might see for complex is imaginary. Doesn't mean they don't exist. It just means they don't exist in the real number system. Okay. If you have concerns about that, let me know. I can explain that to you. So this is what we're going to need to know for the discriminant stuff. Okay. So I'm going to go ahead and clear this out completely. Actually, I'll just leave it for now while I go back to my other share with you guys. If I can. Okay, there we go. So now we get to number 5. We're looking for the value of the discriminant here. So the first thing that we need to do is identify what A, B, and C are. The reason we're doing that, remember the discriminant is B squared minus 4AC. So A is negative 3, B 9, and C negative 1. Remember you're matching to AX squared plus BX plus C equals 0. Okay, so let's find our discriminant. We have 9, the quantity squared, minus 4 times the quantity negative 3 times the quantity negative 1. That's 81 minus 12. which is 69. Okay, so the discriminant is 69. And then for the real solutions, we have to figure out, well, what's the relationship between 69 and 0? Well, 69 is greater than 0, which means your discriminant is positive. Which means you have two real solutions. Okay, for this type of problem for Alex, if it's asking for the number of real solutions, if you get a negative discriminant here, then you would just put 0 real solutions. Okay, so if you have two complex solutions, that's the same thing as no real solution. All right, let me save a picture of that, and then we're going to get into question 6 next. I'm going to clear all this out. And then I'm going to move down. So for question 6, a ball is thrown from an initial height of 4 feet with an initial upward velocity of 21 feet per second. The ball's height, h in feet after t seconds, is given by the following. Okay, so we have this equation here. This is describing some of the details from the equation. We're not going to get into the details of how this equation is formed, but it actually is interesting. If you're going into STEM, let me know if you're concerned about that. Okay, so we're looking at this equation. We want to find values of t for which the ball's height is 10 feet. Okay, so already from this part here, that means h is 10. Okay. And we don't know what t is going to be. For a quadratic equation like this, we can either get 0 real solutions, 1 real solution, or 2 real solutions, which would be the only ones we're concerned about for an application problem. So also do note right here, it says that we're going to be rounding to the nearest hundredth. So make sure to keep that in mind when you're doing this problem. Okay, so essentially what we have here, we have an h to plug in. We keep the rest of the equation. Okay, and then we want to get all of our terms on one side. Since this is a quadratic we're trying to solve. So I'm actually going to start by putting the 10 on the, the right-hand side by subtracting from both sides. So subtract 10 both sides. That's going to give me a -6 over here. And then I could use quadratic formula from here if I wanted to, but I'm actually going to just move all the terms over to the other side, changing the signs of them all and putting them in decreasing order by degree. So add 16t squared to both sides, subtract 21t both sides, add 6 both sides equals 0. Now, for some of these problems, you can check and see if they're factorable. For this one, it's not factorable, especially when you have larger numbers like this. I would just recommend going straight to quadratic formula if another method isn't asked for. So remember, this is matching. We have a t squared. Let me use a different color here. A t squared plus bt plus c equals 0. That's what we're matching to. And our solutions will be given by quadratic formula. Okay, so find your A, B, and C. And then plug into, one more thing, sorry. I just realized this, because when we try to plug in to get the solutions, if we put X, remember we don't have our quadratic in X this time. This is a quadratic in T, since T has the powers of T decreasing from 2 down. So I'm going to make a change here. We're going to change that to a T. So essentially, whatever variable you have for your quadratic, you want the solutions to have the same variable. So these T values here, the T values we're looking for will be equal to negative B. Notice when I have a negative, like an actual negative B value, I need to put parentheses around B so the negatives cancel in the next step. Plus minus square root, we have B squared minus 4AC all divided by 2 times A. Okay, so this part we can simplify. 21 plus minus, here we have 21 squared, that's 441, minus 4 times 16 times 6, 384, divided by 2 times 16, 32. And that's 21 plus minus, we have square root, 441 minus 384. That's 57 over 32. Now note, we already know that we're going to get 2 real solutions for T here because this discriminant is positive. Okay. So I'm going to go ahead and save this picture. Take a picture if you need to. I'm going to clear out the top here. I guess you'll be able to pause. Sorry, there's a garbage truck outside right now. Hopefully you can't hear all that. Okay, so now this is the importance of, a question actually came up in our Zoom meeting yesterday. When do I simplify these radicals using prime factoring versus just plugging in? Well, if you're asked to round your answer to a particular value, you are going to need to plug in. All right, let me close this door. Sorry, the walls and windows are paper thin here. Okay, so what we're going to do, there's going to be 2 solutions. I'm going to emphasize them here. Essentially, you have your 21 plus root 57 divided by 32, or T equals 21 minus root 57 divided by 32. kind of think the reason why this happens for a quadratic, if you were to throw a ball up and then back, throw a ball up in the air, right? So you have this trajectory. So say we're looking for a certain height, in this case it's 10 feet we want. Let me keep it color coded. Okay, then here, at whatever time you get for that height, eventually in due time, you're gonna reach that height again. Because the ball has to come back down. So this essentially is your first time and your second time. Okay, so 21 plus square root 57. Okay, divided by 32. That gives 0.892 and some change, or go back, change that to a minus. Um, 0.420 and some change. Okay, so for the rounding part, you're rounding to the nearest hundredths place, which is right here. So you need to look to the right. Okay. If the number is greater than 4, then you're going to round up. If the number is less than 4, stay. So this one's going to stay at 0.89. Don't forget your units or seconds. And 0.42 seconds. So essentially this first time would be 0.42 seconds after the ball is thrown. And then the second time would be 0.89 seconds after the ball is thrown. Okay. Save that. And I'm going to clear it out in a moment. We're going to move to number 7 next. Okay, so number 7 is a solving equation. We don't have a quadratic form yet, but we're going to see that we do have one when we work out our LCD and get rid of fractions. So I'll just go ahead and do it up here. Okay, so let's think about what the LCD is before we start running out of room here. So LCD, remember the factors that are in the denominators here. We have W minus 1, we have W minus 3, and then for this 1, we just have a 1 underneath. So our LCD, we need to include each of those factors at least once. So W minus 1 and W minus 3 must be included in the LCD. 1 is already always there, right? So remember, you have options of how you do this. I like the multiply by the LCD method because you just get rid of fractions like stat. So I'm going to go with the multiply equation, original equation, by LCD to eliminate fractions. Okay, so I'll do it the long way for this part. W minus 1 times W minus 3. You're going to multiply that by your W minus 5 over W minus 1. Again, you're going to have your LCD W minus 1, W minus 3, the quantities. And you're going to multiply that by W plus 2 over W minus 3. And then you're going to add, we're going to take our LCD again, W minus 1, W minus 3, and we're going to be multiplying that by 1. Okay, so remember, just rule of thumb, this entire multiplied fraction, sorry, no, let me say it again. So these factors that are multiplied up here are both over 1. Same here, same here. So that should help you with knowing why these things are canceling. I typically don't like to put those ones. It actually kind of disturbs my eyes, but if it helps you, keep it. All right, so things that cancel. W minus 1, the factor, cancels with W minus 1, the factor. What are we left with? We're left with the W minus 3 times the W minus 5. Next, what cancels? W minus 3, the factor, cancels with W minus 3, the factor. You're left with W minus 1 times W plus 2. You have your plus between, and the last bit, you just are left with W minus 1 times W minus 3, the factor. Okay. So now what we need to do is expand. Let's do this in a different color. Expand entire equation using FOIL. So remember, that's first, outer, inner, last. You're multiplying those values and adding them up. It's just distribution on steroids. So we have W squared. Let me give myself some space here. W squared minus 3W. Actually, let me go in order. W squared minus 5W minus 3W plus 15. That equals W squared plus 2W minus W minus 2 plus W squared minus 3W minus W plus 3. Okay. So now we need to combine like terms. And solve for W. Okay, so combining our like terms, on the left side, we have W squared minus 8W plus 15 equals, over here, W squared and W squared are like terms. So you have 2 of the W squareds. Here we have 2 minus 1. That gives you 1W here. Okay, and then you have minus 4 more W's here, so minus 5W. Let me just check. Oh, yeah, my bad. Let me just do it in steps. So here, start with this part. That's just going to be plus W. And then here, that's going to be minus 4W. So yeah, caught myself there. And then this last bit, we have -2 plus 3, that's +1. Okay, so keep combining like terms where you can. W squared minus 8w plus 15 equals 2w squared minus 3w plus 1. Okay, let me actually put the solve part in a different color. So that we know, we already combined our like terms in green here, and now the solving for w means we have to get all the w terms, like all the terms to one side of the equation and have a 0 on the other side. So I typically recommend whichever side has the larger coefficient for w squared, try to get all the w squared terms to that side. So let me just do it instead of explaining so much. So here I see I have a 2w squared and I have a w squared over here. So I'm going to want to subtract w squared from both sides. Okay. I also, since I'm moving the w squared terms over to the right side, I want to move the other terms to the right side as well. You could do this in multiple steps. This might actually be preferred. Okay, so cancel, cancel, cancel. If everything cancels on that side, you absolutely need a 0 over there. Here we have a w squared plus 5w minus 14. And then if you got stuck, you could use quadratic formula if you wanted to, but this is actually factorable. Factors into w plus 7, w minus 2. Okay, let me save this. I'm going to clear out the top part here so I can move stuff up. Okay, so let's select all these. All right. Okay, so now basically from here we're going to use zero product property. That's saying w plus 7 can be equal to 0 or w minus 2 can be equal to 0, and that makes this part of the equation true. So w equals -7 or w equals 2. Now, emphasizing, you do need to check your answers. Okay, so when you go back and plug in, you might find that some of these solutions don't work. Particularly, the main thing to look out for is, will I get a 0 in my denominator? So if w came out to be 1 or w came out to be 3, when we plug back in to check, we would have to eliminate those solutions as values. Now, if you do check it, you'll find out that these do indeed work. Let me know if you need help with the check. Remember, check in the original equation. All right, we're moving on to number 8 next. Which is on the next page. So number 8, I think I'm actually going to write down and do on a separate board. Make sure I do this perfectly because I made a mistake in my typing yesterday that created some issue in my video, which you'll later see. So we're trying to solve this particular equation here. Let me stop my share and then go to the whiteboard. It's like you probably hear me clicking this thing and it's just not working. Okay, so clear everything. Okay, so this is chapter 7, homework alternate, number 8. Solve this is what's called a complex quadratic equation. And that's because we don't really see that this equation still has a quadratic form, even though it's a fourth power polynomial. So we're going to find that this particular equation has more than 2 solutions. It can actually have up to 4. But we will be able to solve it like a traditional quadratic by making a substitution. Not like chapter 3 substitution. So don't think about substitution method here. All right, so essentially what I'm going to do to start, I'm going to let W be equal to x squared, and you'll see why in a second. Essentially, I'm taking the square root of this guy here. Okay, so you put some okay, so notice I've filled in my A, B, C values and put the equal 0 on the other side. What I'm going to be putting in here, these parentheses, x squared okay. So note x squared squared is x to the 4th, and x squared to the 1st power is still x squared. Now the reason I have this form, I'm going to replace the x squared with w. And now I have a basic quadratic in W. Okay, and this is actually a 4th degree polynomial in X. All right, so now we would need to factor this traditionally. If it's factorable, go for that. If it's not, use quadratic formula. I will say never really complete the square unless it's comfortable for you or like you're asked to do it. See the last video that I made for completing the square. We'll also encounter it more as we continue. Okay, so let's see. Let's use our AC method here as a recap. I have A is 1, B is -13, and C is 36. A times C is 36. B is -13. What numbers multiply to 36 and add to 13? Negative. Nine and 4. both of which have to be negative. Remember, if you get stuck, start thinking about AC. Break that down into pairs of factors that multiply to 36. So 1 and 36, 2 and, what am I doing? 18. There we go. 3 and 12, 4 and 9, and so on and so forth. Okay. So for this, we actually have our factors. Since A is equal to 1, we don't need to use grouping. So what we get for our factors, excuse me, W minus 9, W minus 4. That equals 0. Okay. So the next thing is going to be to solve for W using zero product property. So W minus 9 can be equal to 0, or W minus 4 can be equal to 0. So W equals 9, or W equals 4. Okay, you might think, yay, I'm done. No, nope, not yet. Because you started with an equation in X, so you need to end in a solution with X's. So what we're gonna do is plug X squared in for W. So X squared is equal to 9, or X squared is equal to 4. Okay. We have square root property coming up next. So that's saying X equals plus or minus the square root of 9, or X equals plus or minus the square root of 4. So we actually end up getting 4 solutions. X is either equal to -3, +3 from here, or -2, +2 from here. Do go back and check, but these ones do work out. Okay, that is problem number 8. We have 2 more problems I want to get through for this video, and then we'll call it quits. You take a pause real quick. All right, so let me clear all this out. I'll stop share, go back to the notes. Come on. All right, so next is graphing a parabola. We've already covered graphing basic parabolas in past chapters, but now we're going to get a little bit more detailed with this. So for number 9 and 10, I want to start introducing a standard form of graphing versus vertex form of graphing. So let me go ahead and move to a whiteboard here. So this is chapter 7, graphing parabolas. Using standard form versus vertex form. So I'm going to put my standard form over here. And standard form is y equals ax squared plus bx plus c. In comparison, there's vertex form. Its form is y equals a times the quantity x minus h squared plus k. You might be thinking, where did the b and c go? Where's h and k coming from? Okay, so first and foremost, let me start with vertex form because it's a little bit less scary to explain once you understand where h and k are coming from. So for one, some details. This is actually true for both, but I'm gonna write it in again. So when A is positive, you're gonna have a happy face looking parabola, and your vertex is gonna be at the bottom of the parabola. The vertex is gonna be either the highest or lowest point of your parabola. And if A is less than 0, you're gonna have a frowny face parabola and the vertex will be at the top. For A greater than 0, the vertex is actually a min. Minimum point. And for A less than 0, vertex V is a maximum point on your graph. Okay, that's one thing. Secondly, your vertex location is going to be HK. So when you get your standard form, like if you started with standard form and you moved into vertex form, which we'll talk about, then you could find your vertex just by looking at H and K, right? The axis of symmetry is a line that cuts your parabola in half. So let's use orange here for this part. The axis of symmetry would be going straight through these parabolas. So just a quick example. I have a parabola and the vertex here is located at 3, 2. Okay. Then you have this axis of symmetry, which is a vertical line cutting your parabola in half. And its equation, remember for a horizontal line, we have x equals a number. X is actually going to equal h for the equation for the axis of symmetry. And h here is 3. Okay. All right. So one more thing to mention about this, how would I get vertex form if it weren't given to me? Essentially, if I take my standard form and I complete the square. On my function, then I actually get to vertex form. In comparison, if I'm trying to get to vertex form, if I'm trying to get from vertex form to standard form, I would actually just expand and combine like terms. Okay. All right, so then let's get into our standard form now. Details. A greater than 0, A less than 0 will be the same rules. Okay. Your vertex is still technically located at HK, but there's a formula for it. H is actually given by negative b over 2a. And k is the function value at negative b over 2a. Okay, so your vertex v, which was hk, is now at negative b over 2a, f evaluated at b over 2a. Now you might be saying, wait a minute, like where is this function coming from? Remember, we talked about this previously. You can represent y as f of x. Okay, so if you're trying to find your vertex, you would find h first, which is negative b over 2a. And then you plug that value in as x and solve for y to find what the function value at h is going to be. Okay. And then the axis of symmetry. Same general rules over here. Remember, you had the equation x is equal to h before, so now x is equal to negative b over 2a. That's the equation of the axis of symmetry. All right, so far so good. You save that. And then I'm going to go back to the notes here. So notice, essentially the reason why it's not going to be as easy to graph these as it was in previous chapters, we have shifts here and stretches. So the shift would be from here and the stretch would be from here. You're going to want to know where your max or min point is for your parabola. That way you can just find corresponding values on either side of that vertex. So you'll see what I mean by that in a moment. So first and foremost, I want you to notice that number 9 is given in standard form. This would be f of x equals negative 4x squared plus 0x plus 4. Okay, that means that a is negative 4, b is 0, and c is positive 4. So the first thing that we're going to want to do is find the vertex. Okay, over here, the reason why we're doing this, we're going to be plotting a chart, x versus f of x, and we actually want to use 5 values here. 5 values of x to give us 5 values of y. just like we were doing before. Except now we specifically want the vertex to be in the middle. So vertex should be right here. Here, remember the vertex, you're gonna need to find, I actually like to still write it as HK. You have a choice if you wanna do that. And then I just write H is equal to negative B over 2A, and K is equal to F of negative B over 2A. So H is negative 0 over 2 times negative 4, which is just going to give you 0. Okay. Note this is always in the middle going to be H. And then K, what you're going to do, you're going to plug 0 into the function here. What is f of 0? So I have negative 4 times 0 squared plus 4, which is just 4. So my vertex is at 0, positive 4. Okay. Now my second step find for x values that are symmetric. Symmetric about the vertex. So like if I have 0 in the middle and I put negative 1 over here, I want to put 1 on the other side because those are both a distance of 1 away from 0. If I put negative 2 up here, I want to put positive 2 down here because they're at the same distance from 0. Okay. And then step 3, find y values. And that's done by plugging in, right? So you can use a calculator for this part if you wanted to. I'll just go ahead and go over one of these. Let me save this and clear out the side. Okay, so like remember if you're trying to plug in, and let me actually just do this in a different color so it's kind of more emphasized. So you have x equals negative 2, for example. So f of negative 2 is negative 4 times the quantity, put in parentheses, negative 2 squared plus 4. That's negative 4 times positive 4 plus 4. Remember, review your exponent rules. That's negative 16 plus 4, which is negative 12. Okay. Just double check here just to make sure. Yep. Okay. So we actually get negative 12 here. And then to check that we found our vertex correctly, when we plug in 2 and solve out for y, we should get the same thing. Negative 4 times 2 squared plus 4. That's negative 4 times 4 plus 4, which is negative 16 plus 4, which is negative 12. Okay. So negative 12 for both of these. Now I'll go ahead and make it a little faster for this next bit and just plug in. Let me plug in negative 1. You get 0. Let me plug in positive 1, just to double check, you should also get 0. Yep. So let's make our other points. We have -1, 0, +1, 0. This one's actually kind of steep, right? We have -2, -12, and +2, -12. So sorry, it's gonna be really hard for me to graph this, but basically you want to curve out as much as possible. That is so ugly. And then just make sure at the top, that's so ugly. Okay, make sure at the top here, curve it. Don't make it pointy. Okay, otherwise that's an absolute value graph. All right, of course, Alex will definitely make that smoother for you to graph. It's not gonna look as ugly. All right, so I do want to go over one more just because I have the time right now, and I would like you to start reviewing as early as possible so that we can get into final reviews as early as possible. Excuse me. All right, so let me go ahead and clear this out. And then let me move down here. All right, so we have this last parabola that we want to graph. And I just want to make note that this is vertex form here. That's okay, yeah, but why? Y equals a times x minus h, the quantity squared plus k. So I just want you to be very mindful that you need to be very careful finding h and k. Oftentimes these signs are switched and that'll mess up your graph quite a bit. So let's actually match this equation here. So we have a, that's 1, we can leave that off. X minus is what I want to match to. So that means h must be -3. Okay, that's squared. Then you have plus, which you're trying to match to, right? So that means that k is 4. I swear those all look like the same color. Let's make it purple. So off to the side over here, we found that A is 1, H, -3, K, 4. Now the beauty of this is that you don't actually need to solve for H. Okay, you're already ready to make your table here. Tripping over all kind of words today. All right, so we're gonna have our X values and our f of X. Give yourself enough room for 5 of these values. Remember that the vertex is going to be nice and in the middle here. Let's emphasize it. Vertex is HK, so vertex is at -3, +4. Okay, and then from there we want to find symmetric X values about X equals -3. So some decent values you can use. Use another color here. Might not pink. Okay, so if we put -2 on this side, that looks exactly the same. Maybe it looks different to you guys, but it looks exactly the same to me. Let's use green. Okay, so if I put -2 on this side, kind of think, what should I put on the other side? -4. And then if I put -1 up here, -5. Now you normally put these the other way, but it's really not worth changing. I would just say try not to put all your numbers randomly. Either have them in ascending order or descending order. Okay, so now we're just going to plug in. You already saw how we can plug in with the last bit. Actually, it's a little different. Let's show it. So up here, when x is equal to -1, you have y equals -1 plus 3 squared plus 4. That's 2 squared plus 4. That's 4 plus 4, which is 8. Let's check when x is -5 to make sure that we get the symmetry we're looking for. So we have -5 plus 3, the quantity squared, plus 4. That gives me -2, the quantity squared, plus 4, and that's why this works. Because we, again, get 4 plus 4, which is 8. And there's the symmetry we're looking for. So we'll just go ahead and plug in for the rest here. We have -2 plus 3, the quantity squared, plus 4. That should give us 5. So we should also get 5 when we plug in -4. Vertex will emphasize in orange. We have start at the origin, -3, +4. Kind of think, should you get a min or a max for your vertex? Well, A is positive, right? So you're going to get a min for your vertex, which you should see from graphing anyway. So -2, boop, 5, -4, 5, and we have -1, 8, -5, 8. So we have a parabola that looks like this. Anyway, you guys get the point, hopefully. Curve it out. Yeah, so you won't have this problem when you're graphing in Alex. Just be careful if you have to go into future math classes and draw it out. All right, so that concludes problems number 5 through 10 from the Chapter 7 assignment. Please review all that, look at these videos, skim through them, do whatever you have to do to work through everything, and let me know if you need extensions, honestly. I will see you guys hopefully in a few days.